Welcome to the lecture 2 of course Business Analytics and Data Mining Modeling using R. In this particular course, in this particular lecture, we are going to cover the data mining process. So there are different phases in a typical data mining effort. So first phase is about first phase is named as discovery. So important activities that are part of this phase are framing business problem. So first we need to understand the needs of the organization and the issues they are facing, and the kind of resources that are available, the kind of team is available, the kind of data repository, other resources are available, and the try to understand the main business problem, and then try to identify the analytics component. So analytics challenge or analytics component part of that particular business problem. Then we start understanding we start to develop our understanding about the relevant phenomena, the relevant concepts, constructs, variables, and we try to develop or formulate our initial hypotheses that are going to be later on converted into a data mining problem. So this is in the discovery in the first phase. These are some of the activities that we generally have to do. The next stage is the next phase is data preparation. In this phase we have already understood the problem, especially the analytics problem that we have to deal with. Therefore we also based on our initial hypothesis formulation, will also have understanding about the kind of variables that would be required to perform the analysis. Therefore we can always look for the relevant data from internal and external resources, and then we can compile the data set, and that can be used for the analytics. So another activities that can actually be performed in this stage also data consistency checks. For example, data can come from a variety of sources. Therefore we need to check the definition of fields, whether they are consistent or not. We also need to look for units of measurement. We also need to check for data format, whether that is consistent or not. For example, if you have a variable gender in your data set, and in one particular source it is recorded as male, MALE, and in another male and female, full form, MALE and female, and in another from another source it is recorded as capital M or capital F. So therefore you have to make sure that data is consistent, and when the whole data is compiled or brought together, then these consistency have to be checked. Then time periods. So data could be belonging to a particular number of years, so that we also need to check, because the analysis or results could actually be limited by the time period as well. Sample. Now we don't always need all the records that we prepare in our data set. We generally we take a sample of it, because a smaller sample of the that is generally good enough to build accurate models. Now next phase in a typical data mining effort is about data exploration and conditioning. So in this phase we generally do activities like missing data handling. We also check for range reasonability, whether the range of different variables, they are in the expected they are as per the expectation or not. We also look for the outliers. They can come due to some human error or measurement error, etc. Graphical or visual analysis is another activity. So we generally plot a number of graphics, for example histogram, scatter plot, that we are going to discuss in a later coming lecture. Other activities that we can do is transformation of variables, creation of new variables, and normalization. So why we might need to do some of these activities would be more clear on as we go further in coming lectures. Transformation, creation of new variable. For example, sometimes we might require that sales figure has to be in more than 10 million or less than 10 million kind of format, then we might have to transform our variable, creation of new variables. So if we do some of these transformation, we will end up with some of the new variables. Sometimes we might use both the forms in our analysis. Normalization, sometimes a scale could pose a problem in a particular data mining algorithm or statistical technique, so therefore normalization might be required. So these are some of the activities that we have to do. Partitioning is another essential part of a data mining modeling. So we generally partition our data set, our sample into training, validation and test data sets. Training is generally the large partition, and all the models, all the algorithms, they are generally applied on the training data set, and then fine tuning or selection of a particular algorithm or particular technique happens on the validation data set. Test data set is again re-evaluation of that final method. Next phase of data mining process is model planning. So in this particular phase, we need to determine the task that we have to perform, whether it is a prediction task or a classification task. We also need to select the appropriate method for that particular task. It could be regression, neural network, could be clustering, discriminant analysis, and many other methods that we are going to discuss in coming lectures. Now next phase is model building. Building different candidate models using selected techniques in the previous steps and their variants. So that is done using training data. Then generally we refine and select the final model using the validation data. Then evaluation component that happens, the final model that is done on test data. So in this phase mainly we try out different candidate models, we assess their performance, we fine tune them, and then we finally select a particular model. Now next phase is results interpretation. So once model evaluation happens using performance matrix, we can go on and interpret the results. So one is the explanatory part, then another one could be the prediction part. So all those interpretation can actually be done in this particular phase. And then the model deployment. Once we are satisfied with the model that we have, we can run a pilot project so that we are able to integrate and run the model on operational systems. So that is the last phase. Now this is the typical data mining process that one has to follow. Similar data mining methodologies were developed by SAS and IBM Modeler, that was previously known as SPSS Clementine. So these are the commercial software for statistical modeling and data mining modeling, and they also follow a similar kind of data mining methodology. So for SAS methodology is called SEMA, SEMAA, and the IBM Modeler's methodology is called CRISP-DM. Now at this point we need to understand the classification, important classification related to data mining techniques. So data mining techniques can typically be divided into supervised learning methods and unsupervised learning methods. Now what is supervised learning? So in supervised learning, algorithms are used to learn the function f that can map input variables, that is generally denoted by x, into output variables, that is generally denoted by y. So algorithms they are used to learn a mapping function, a function which can actually map input variables x into output variables y. As you can also write this as y as a function of x. Now the main idea behind this is we want to approximate a mapping function f such that new data on input variables can actually be used to predict the output variables of y with minimum possible error. So that is the main idea. So the whole model development that we do is, and this learning of this function is actually performed so that on new data we are able to predict the outcome variables with minimum possible error. Now supervised learning problems can be further grouped into prediction and classification problems that we have discussed before. Now next is unsupervised learning. So in unsupervised learning, algorithms are used to learn the underlying structure or patterns hidden in the data. If we look at the examples, again unsupervised learning problems can be grouped into clustering and association rule learning problems. Now there are some other key concepts that can actually be we need to discuss before we move further. So some of these concepts are related to sampling. We don't need to go into detail of all the sampling related concepts. We will need what is mainly applicable, what is mainly relevant to a data mining process. So we need to understand the target population. So how we define a target population? Target population is the subset of the population under study. For example, in our sedan car example in the previous lecture, it is the household that were the target populations. If we wanted to study the household and whether they own a sedan car or not. Now results, whenever we study a particular target population, it is generally understood that results are going to be generalized to the same target population. Now when we do an analysis, we don't gather all the data coming from the target population. We take a sample of it. Reason are, as we have discussed or indicated before, cost related problems. We cannot actually go about collecting data from the whole population because it is going to be a very costly process. So therefore the whole purpose of business analytics, data mining, modeling and other related discipline is to reduce this cost and still have some useful insights or solve some of the analytics problems. So that is why we require sample. So we generally take a subset of the target population and then analyze the data that we have in that sample. So generally in our data mining scope, generally we might be mainly limited to simple random sampling, which is a sampling method wherein each observation has an equal chance of being selected. Now what is random sampling? So a sampling method wherein each observation does not necessarily have an equal chance of being selected. Generally simple random sampling is used where each observation has a equal chance of being selected. The problem with simple random sampling could be that sometimes the sampled population could not be the represented or could not be the proper representation of the target population because of this equal probability of each observation being selected. This could be one problem. Sampling next is sampling with replacement. So when we do sampling with replacement, so when we pick an observation and then that observation is placed back in the sample, then again for the next value it again has the equal chance of being selected. So in sampling with replacement, sample values are independent. So once an observation has been once an observation or case has been selected, again the next observation doesn't depend on this the first selection. It can again be the same case or some other case. So sample values are independent. When we say sampling without replacement, sample values aren't independent because once a particular case or observation has been selected, because of the this without replacement procedure, we cannot put it back there. So therefore the remaining observation we have to select from the remaining cases. Therefore the next selections are going to be dependent on the previous selection. So that is why sample values are not independent. Now whenever we do sampling, it is going to result in less number of observations than the total number of observations that are present in the data set. Now there are some other issues that could again further bring down the number of observation or variables in your sample. For example, data mining algorithms. So different data mining algorithms, they could have varying limitation on number of observation on variables. They might not be able to handle more than a certain number of observation or more than a certain number of variables. So that could be one limitation that could again limit your sample size. Now limitation can also be due to computing power and storage capacity. So the available computing power and storage that you have for your analytics purpose can also either lower the speed or limit the number of observations or number of variables that can be handled. Similarly, limitation can also be due to statistical software. Nowadays you already understand that different software, they have different versions. So generally, if you are using a free version of a commercial software, that can actually limit the number of variables or number of observations that can actually be studied. So those limitations can further bring down your sample size. Now while we are discussing this about limitation related to number of observation, we need to understand how many observations are actually required to build accurate models, because the whole idea is to build accurate models, build good models, so that we have good enough results which could be used in production systems later on. Especially when we understand that the we cannot get the data from the target population, we have to take a sample. So cost is an important factor. Therefore it is always better for us to understand the number of observation, number of sample size that would be sufficient for us to build accurate model, robust models. Now there are many other concepts related to data mining process that we need to understand at this point. Sampling size will come back again. Now next concept is rare event. Now typically when you are dealing with a particular data set, if it is a classification problem and you have a outcome variable where you have for example ownership that we talked about, whether a household owns a car or not, so owner or non-owner. So that kind of scenario is there. So typically the split between observation belonging to owner class and observation belonging to the non-owner class, they would be 60-40 or around 50-50 or that kind of ratio. But it might so happen that in a if it is a rare event that out of let's say 1000 households, only 10 or 20 household actually own a sedan car, then in that case it will make it a rare event. That ownership of a sedan car could actually be a rare event in a particular target population. So in that case, how do we do our modeling? Another example would be low response rate in advertising by traditional mail or email. So you might be having different promotional or marketing advertising offers through coming to you through traditional mails, post and emails as well. Now not everyone is going to respond to those offers. So again, this can also be a rare event. So how do we do our modeling? What are the issues that we face in these kind of situation? See, if you have a particular class which has very few observation belonging to very few observation actually belong to that class, so any kind of modeling that you are actually going to do using that particular data set might not give you an good enough model, right? It might become very difficult for you to get a model, build a model that will satisfy your main analytics goal. For example, if you have 100 observation in your data set and 95 belong to the non-owner class and 5 belong to the owner class, and main objective of your business problem is to identify people who are owners. So therefore, even if you don't build a model still and you classify every household as a non-owner, still you will get 95% accuracy of your model. So in this case, modeling for the success cases becomes an issue. So how do we solve this problem? We do oversampling. So we do oversampling of success cases. So that means we include more, we duplicate many of the data points which are belongs to the success case, or we change the ratio. That means we take the success cases data points observation, and we also take the observation which belong to the for example, we take the observation belonging to the owner class and we take the observation belonging to the non-owner class in a 50-50 kind of ratio or similar ratio. This kind of problem again arises mainly in classification task. Now, another related concept to this problem is cost of misclassification. So, when we say that success class is more important for us, we are dealing with asymmetric cost here, right, because identifying success class is more important for us, because it is more important for us to understand which customer is going to respond to our email promotional offer and marketing offer. So, therefore, we are essentially dealing with asymmetric cost. Now, generally if we are not able to identify success cases, generally the cost of failing to identify success cases is going to be more than cost of detailed review of all cases. Reason being, if you are able to identify a particular customer that he or she is going to respond to your offer, then probably the profit that you can earn by selling your product or services to that customer would actually be more than the cost of detailed review of cases. So, therefore, generally the benefit of identifying success cases is higher than that, and that is why modeling becomes premium. Another important aspect of rare event is when a success case is important for you. Now, prediction of success cases is always going to come at a cost of misclassifying a failure case as a success case, because if you, out of 100 observation you have only 5 success cases, you would like to identify all those 5 so that you are able to make a profit from your offerings. So, therefore, eventually the model that you build, you might end up with identifying many failure cases also as the success cases. So, therefore, this is going to be more than usable. So, usually if you have 50-50 case of success class and success cases and failure cases, your accuracy or your accuracy and error can be on the lower side, but in this case error would actually increase, but the purpose is to identify success cases to increase the profit. Now, another important aspect of data mining process is dummy coding for categorical variables. Now, there could be some statistical software which cannot use categorical variables expressed in the label format. If you have format, for example, if you have variable like gender, where you have male and female or M or F has been, those are the labels that are there in the data set. So, many statistical software might not be able to use this particular variable directly. So, therefore, dummy binary dummy coding might be required for these variables. When we say dummy coding, we actually create dummy binary variables. So, these are actually having zeros and ones, 0 indicating the absence of a particular type and 1 indicating presence of a particular type. For example, if activity status of individuals, we have data on activity status of individuals and has 4 mutually exclusive and jointly exhaustive classes as student, unemployed, employed and retired. Then in that case we can create a different dummy variable wherever when a particular observation, if its activity status belongs to a student, it will have the value as 1. If it does not, then it will have the value as 0. Similarly for other observations and for other classes. Now, if these classes are mutually exclusive and exhaustive, then we do not need to create all 4 dummy variables. If there are 4 types, we do not need to create 4 dummy variables, because them being jointly exhaustive, we know 3 of them, then the 4th one is already known. So, therefore, we need to create only 3 dummy variables. Now, another important concept is principle of parsimony. So, principle of parsimony is about when a model or theory with less number of assumptions and variables, but with high explanatory power is generally desirable. So, you are always looking to develop a model or theory where you make as few assumptions as possible and you include as few variables as possible and still able to explain most of the phenomena. higher explanatory power. Most of the cases you are able to explain, and less number of you must be using less number of assumptions and variables. So this is a desirable property, and in this particular course we will be putting more emphasis on this particular principle. Now another problem with more number of variable is that it is going to increase your sample size requirements, because you are always looking for a reliable, you always want to estimate, you always want to compute a reliable estimate, and if you have more number of variables, then your sample size requirement will increase to have that higher reliability. Now another related problem is overfitting. So what is a overfitting? So overfitting generally arises when a model is built using a complex function that fits the data perfectly. So if your model is fitting the data perfectly, then probably it might be overfitting the data. So what actually happens is you end up overfitting, you end up fitting the noise, your model end up fitting the noise and explaining the chance variation. So you would actually look to avoid explaining chance variation, because you are looking to understand the relationship which can then be used to predict the future values, right. So therefore overfitting is something that is not desirable. Overfitting can also arise due to more number of iterations. If you do more number of iterations, that can result in excessive learning of the data. So that can also lead to overfitting. If you have more number of variables in model, some of those variables might have a spurious relationship with your outcome variables, right. So that can also lead to overfitting. Now the next concept is related to sample size. So how many observations should actually be good enough for us to build an accurate model? So domain knowledge is the is important here to understand the sample size, because as you do more and more modeling, more and more analytics, you would be able to understand different phenomena, the construct concepts of variables. You will have a better hunch on, or better rule of thumbs to understand how many observations will actually be able to build a model for a particular analytics problems. So domain knowledge is always going to be the crucial part. We also have rule of thumbs. For example, if you have p number of predictors, 10 into p, so for 10 observation per predictor can actually be a good enough rule of thumb to determine the sample size. Similarly, for classification task also many researchers have suggested some rule of thumb. For example, 6 into m into p observation, where m is the number of classes in the outcome variable and p is the number of predictors. So that can actually help you determine a sample size. Now another relevant concept is outlier. Now what is an outlier? So outlier can briefly be defined as a distant data point. Now important thing for us to understand is whether this distant data point is valid point or erroneous point, because the if a particular data point is distance from the majority of the values, or very distance from the mean, more than 3 standard deviation away from the mean, then it could be due to human error or measurement error. So we need to find out whether a particular data point is because of the human error or measurement error. For example, a temperature, a value of 100 or 150 for a room temperature or temperature in a city could be human error or measurement error. Sometimes there could be errors due to decimal points and related typing error and all that. So we need to identify whether a particular outlier, whether it is a valid point or erroneous value. So how do we do that? So generally you can do some manual inspection. You can sort your values and find out if anything looks out of place. You can also look at the minimum and maximum value, and from there you can try and identify whether they are outliers, whether they are errors. Clustering can also help you. So, you can do clusterings, you would be able to see and whether a particular point is outlier or not. Domain knowledge. So, domain knowledge is also going to help about this. Now, next related concept is missing values. You might come across a data set which is very important for your particular your particular business analytics problems, but few records have missing values. So, if the those records are few in numbers, then probably you can remove those records and then go ahead with your analysis. But if the number of records are more, then probably that can end up eliminating most of your observations. So, therefore, you need to handle those missing values. Imputation is one way. So, you impute those missing values with the average value of that particular variable, right. So, that could be one solution. You can also, if that is also not desirable, then another option is, if you have many missing values, then you can identify the variables where the missing values are there, and if those variables are not very important for your analysis, then probably you can think about dropping them. If those variables are important for your analysis, then probably you can look for a proxy variable which is having less number of missing values and replace that particular variable with their appropriate proxy variables. Another important concept is normalization. Many times and many techniques would actually require different variables. It would require for you to normalize different variables. For example, distance based techniques, clusterings and other, where distance is an important computation, important part of the process, important part of the algorithm. Different variables having data in different units can actually create problem. They can actually dominate the computation related to distance, and therefore can influence the results. So, in many scenarios, normalization is the desired thing in the data mining process. So, there are two popular ways of normalization. One is a standardization using Z-score, where you subtract each value by subtract by mean and divide by standard deviation. Then there is another min-max normalization, where you subtract each value by the minimum value and then divide by the difference of max and mean. So, these are the key differences. Thank you.